Hi everybody. So in today's video, I'm going to be introducing you to one of the new ideas that we're going to have in this unit, which is the idea of a differential equation. So I'd like to start by just explaining what a differential equation is. A differential equation is an equation involving one or more derivatives. An example of a differential equation could be something as simple as dy over dx equals 3x squared minus 7, because this is the equation of a derivative. However, differential equations can get a little bit more complicated. So another example of a differential equation could be something like 3y prime plus 4y double prime equals 8y. The reason that this would be considered a differential equation is that it's an equation that has the first and the second derivative in the equation. Now, when we're solving a differential equation and when we're working with differential equations, there are a couple of vocabulary words that we're going to need to know. So our goal for today is going to be to interpret verbal statements. So interpret verbal statements. So we're going to read some words as differential equations. So we're going to read some words and set up equations. And therefore, we're going to need to know what some of these special words mean. The word directly proportional. So when the relationship between two quantities is directly proportional, it means that one quantity can be calculated by multiplying the other quantity by a constant. An example would be like this: y equals k times x. We would say here that y is directly proportional to x because the k in this equation represents a constant, some number that we may or may not know already. We call k the constant of proportionality. So an example where we know the constant would be y equals 5x. So these two variables, y and x, are directly proportional. Another special type of relationship and some vocabulary that we need to know is the word inversely proportional. When the relationship between two quantities is inversely proportional, it means that one quantity can be calculated by multiplying the other quantity times a constant. And inversely means that instead of multiplying by the other variable, we're going to divide it. So that example would be y equals k divided by x. So this should actually say dividing the other quantity with a constant. I apologize, that was a typo. In this example, k is still a constant. But instead of multiplying by k, we're setting up an equation where k is a numerator and x is in the denominator. An example would be y equals 5 divided by x. We still call k the constant of proportionality. Let's take a look at what some of these problems are going to look like, where we're going to be reading the words and we're going to be trying to set up an equation based on what the words say. Now, these are examples of multiple choice questions that are directly off of AP Review. So these are very similar to questions you might expect to see on the AP test. A jogger runs along a straight track. The jogger's position is given by the function p of t, where t is measured in minutes since the start of the run. During the first minute of the run, the jogger's acceleration is proportional to the square root of the time since the start of the run. Which of the following is a differential equation that describes this relationship where k is a positive constant? The key thing here is to realize, actually, there are two key things, I guess. The key thing here is to realize two things. We are looking at the jogger's position. So p of t is the position function. And that's important because another thing we're going to be asked to think about here is the acceleration. So we're going to need to know the relationship between position and acceleration. The second important thing to realize here is that this second sentence is basically the sentence that we're going to turn into an equation. It says during the first minute, The jogger's acceleration is proportional to the square root of the time since the start of the run. That is a sentence that becomes an equation. So, what is acceleration? Well, if we're thinking about how acceleration is related to position, acceleration would be the second derivative. So the first derivative would be velocity, and the second derivative would be acceleration. So we would say d squared p over dt squared. The reason we're saying squared here is that the first derivative would have been velocity, but the second derivative is acceleration. Now, it says in this sentence that the acceleration is proportional to. Proportional to is another way of saying directly proportional. We would have to specifically use the word inversely proportional to mean inversely proportional. If it just says proportional or directly proportional, those are the same thing. So that means that our equation is going to be equal to k, some constant, times whatever comes next. We are proportional to the square root of the time. So I would write square root of t here because in this problem, t is the variable that represents time. Well, if I'm looking at my answer choices, it seems to me like the answer choice that best matches the equation that I wrote would be option C. If I'm thinking, for example, about why option A would not be the correct option, they've got the correct equation on the right side, but the left side is just the first derivative of position, which would just be velocity. And it specifically says here that we're thinking about acceleration. If I'm thinking why option D would be incorrect, it's because even though they have the acceleration side of the equation set up correctly, k times the square root of p would be if this had said the square root of the position since the start of the run. We're going to go ahead and skip the next example. We'll do that one in class as a warm-up, and we're going to look at the next page. So the second target of today is the idea of verifying solutions to differential equations. Now, verify means to determine if a solution is correct. So it's not asking you to find a solution for yourself. It's asking to test whether a given possible solution actually is the correct one. A solution to a differential equation can be found or verified by substituting the function itself and its derivatives into the equation that is a differential equation. And we can do this in an example problem like this. Again, this is a multiple choice question that is straight off of an AP test, so this is very similar to things you might want to see. And I am going to warn you, this problem is going to get a little algebra-y, so hang with me here, you can do this. This is the differential equation. And the reason that this is the differential equation is that this is the equation that has derivatives in it. You'll notice it has a second derivative. This is what we're testing to see if it's a solution. It says for what value of k. So you'll notice there's a missing number here. So for what value of k would this equation be a solution to this differential equation? You'll notice that the differential equation has a y and a y double prime. So in order to perform our substitution, we need to know y, which we already know, and we need to know y double prime, so the second derivative. Before I get going with my substitution, I'm going to go ahead and kind of line up everything that I need. I've already got y, so my next step would be to find y double prime. So in order to get to y double prime, I'm going to start by finding the first derivative. Now the derivative of e to the something is just e to the something. But in this case, I would need to multiply by 2 because of chain rule. So the derivative of e to the 2x would be e to the 2x times 2. The derivative of, again, e to the something is just e to the something. Don't let this k throw you off. K just stands for a number, so it doesn't change how we do the derivative here because it's just a constant that you're multiplying by your function. So my derivative would be k e to the negative 3x, and then I would multiply by negative 3 because of chain rule, for the same reason that I multiplied by 2 here. Now this is the first derivative, and before I do the second derivative, I want to simplify my life a little bit by just rewriting this in a friendlier way. So my rewritten equation would be 2 e to the 2x minus 3k e to the negative 3x. After I've got my first derivative, I'm going to go ahead and find my second derivative because that's what I'm going to need in order to perform this substitution into this equation. So the second derivative is going to be kind of similar to how we did the first derivative since we're working with the function e to the something, which means the derivative is itself. So my derivative here would be 2 e to the 2x, and again I'm going to multiply by 2 because that's the chain of this exponent, minus 3k e to the negative 3x times negative 3, again because that's the chain rule. Finally, I'm going to simplify my life a little bit again by just simplifying this second derivative. So I would have 4 e to the 2x plus 9k e to the negative 3x. Now, in order to perform the substitution into this equation, I need y, which is the original, and y double prime, which is the derivative. Since the original was already here and the second derivative is here, I'm ready to perform my substitution. So the third step would be to plug all this stuff in. Instead of y, I'm going to replace the y here with my original equation from here. So my substitution is going to look like this: 4 and then parentheses e to the 2x plus k e to the negative 3x. Then I'm going to copy down the minus from this differential equation, and I'm going to replace the y double prime with this second derivative that I found. So I'm going to have parentheses 4 e to the 2x plus 9k e to the negative 3x equals 10 e to the negative 3x. I'm just copying that down. Now this looks really complicated, but I think if we work through some of the steps here, you're going to see that our life gets a little bit easier. Remember, our goal is to find k. So our goal is to get k by itself. We're going to go ahead and simplify this, and first thing we're going to do is distribute this 4. So I'm going to distribute the 4 to both of the terms inside of this parentheses. So 4 e to the 2x plus 4k e to the negative 3x. I'm also going to distribute this negative, so minus 4 e to the 2x, and then minus 9k e to the negative 3x. And I'm going to copy down the 10 e to the negative 3x. Just copy it down, don't change anything. Once I've done that distribution, I notice something kind of exciting happens. This 4 e to the 2x and this minus 4 e to the 2x cancel each other out. So right away, my life got a little bit easier. I'm also noticing that both of these terms that remain have like terms. They both have e to the negative 3x. If I have 4k e to the negative 3x minus 9k e to the negative 3x, those combine to make negative 5k e to the negative 3x. And again, I'm just going to copy down the equals 10 e to the negative 3x. Now I'm noticing, again, something kind of exciting happens. This e to the negative 3x and this e to the negative 3x are the same on both sides. So if I divide by e to the negative 3x, though that part of my term on each side is going to cancel, which means the equation that I'm left with, so from all this complicated stuff, the equation that I'm left with is negative 5k equals 10. Now that's an equation that I'm pretty confident we can solve. If we divide by 5, we get k equals negative 2. So for what value of k will this be a solution to this differential equation? Negative 2. All right, thank you guys so much for watching. I will see you in class. We will do one problem for a warm-up, and then we will do some practice problems.